Hello, hi everyone. Welcome to this demo session that I will be conducting today. I will be your trainer for sessions and training on data modeling, where we will understand what is data modeling, how to do that, what are the tools available which we can utilize to uh, do the data modeling or becoming a data modeler, why it is necessary, what are the requirements, and what are the best practices to do so. Okay, so data modeling is a vast concept. Okay, if you go with the definition, what exactly data modeling is, so you can see here data modeling is the process of creating a visual representation of either a whole information system or parts of it to communicate connections between data points and structures. So this is a very, you know, technical, or I can say not so easy to understand definition. But throughout our session, we will understand exactly how we can, define a data model and the process of data modeling and how exactly we do that. So if I tell you in the layman terms what data modeling is, for example, um, whenever you start something, whenever, for example, you want to create an airplane, how you will start? Obviously, you will not start simply designing the airplane. You will not simply start, you know, um, assembling the different spare parts together and to develop the airplane. No, it will not happen like that. Before doing that, you will first need a blueprint, okay, just like the one you are seeing right now. You need a blueprint where you will see how exactly your output will look like. Is everything is fine mathematically, technically, and your prototype is working very fine. Okay, once this is finalized, once you are okay, like you have done your hypothesis testing, you have done your, you know, um, mathematical calculations like using these dimensions and everything, your aeroplane will fly and it will work perfectly. Only then you are going to invest a lot of time, a lot of resources, a lot of money to um, develop this. Similarly, when we where we are storing data these days, so these are databases are you can say silos where we put the data into. They are the container where we put data into. So before creating a database which is actually storing the data, we first need to know what is the blueprint. Like, we will be seeing a lot of data points in our data. There will be a lot of information in different forms. Sometime data will be structured, sometime data will be unstructured. So how exactly we will make or set up a communication between the different data points so they can communicate with each other, assemble them perfectly, just like this aeroplane you are seeing right now, and then we will input some data into that. Otherwise, what will happen, if let's say you are talking about big data, okay, million rows, billion rows, and you somehow put a lot of resources to do that, you put them into um, a database without discussing much about data model, then later you will see, oh, I forgot to do this, I forgot to do that. So this will become a problem. So for that, you will need to set up a data model. One more need of data model is to create data model is to make an efficient read and write operations to your data. For example, if I want to fetch some information, how easily and efficiently can you can do that. That is also a feature of a good and efficient data model. So if I will show this picture to you, and whenever we think of data model, we basically think about something like this. Okay, a lot of tables, a lot of fields. Like, for example, here you see orders. Within order you see order ID, customer ID, then you have order details. This is talking to this. This is talking to another table, which is further talking to two other tables, like that. So yes, this is something we can consider as a blueprint, which we first decide like how we should put our data into, and then we finalize and actually create a database. Database is your data model plus data. If we remove data from your database, it will just remain your data model. And there is one more concept that we will, these it is very popular these days. People want to learn it. This is called reverse engineering your database. What exactly that means? For example, you have this data model. On top of that, you are loading data for 10 years. and you suddenly join some organization and you see, hey, I have a database, but you don't know how these things relate to each other. Then what you need to do, you will reverse engineer that and then will find, okay, what are the relationships between these entities, what exactly this attribute means, all these things. That is called reverse engineering in terms of database, and you will have to do that if you want to understand how exactly data is set up. Otherwise, you will not know how your database is working, and if there is a change you are supposed to do, you will never understand. You can mess things up, so that is required. So this is something we can consider as a data model, but this is not the only way to keep your data as. Okay, there are different techniques, there are different modeling techniques that are popular. Some are primitive, like started way back in time, and some are modern techniques. Okay, if I show you this picture, you will see five most popular data modeling techniques that we are going to cover within our course. We will focus more on the popular ones, that is relational, and you can see ER, that is entity relationship modeling technique. But you will also see some complex and very advanced modeling techniques that generally used within a lot of computer languages, like when you will do the modeling using some high level programming language. So you can use object oriented data modeling techniques as well. But for you, we will be focusing more on BI related models, that is ER, and relational. Network is also possible, like popular these days, but we will focus on entity relationship and relational. Okay, if you want something very specific, yeah, we can cover that. But yeah, these you will find a lot of tools following these two methodologies or techniques. Okay, for each of these techniques that you are seeing here, there are some governing regulations, some rules that you need to follow to make sure that your data is perfectly modeled and you will not have problem on a long run. So that's how we will going to pursue this course. Now, if I tell you what exactly are the features of a good or efficient data model, first of all, it should comply with all the business requirements, and that is your first task to understand business requirements when you create a data model. For example, there is a table where you're storing a lot of data about employees, and I have very strict policies that within database I should not have two employees with same name, same address, or along with that same father's name, something like that. So this is a business requirement. I don't want. Obviously, it's also a best practice. You will never keep duplicates, but still, if you want to follow all these requirements, for example, there can be another requirement that I want to make sure that if I have a transactional data, for example, you are e-commerce website that is doing a lot of transaction on daily basis, I want to keep two different views of my data. One at transactional level, like I want to see transaction by transaction, and then a summarized view. Okay, and then I want to I only want to keep copy of data that are related to a specific product segment, and the other segments, like rest of the segments, are not that important, so we can archive that. So all these requirements which business actually need uh, will be the base of your data model, and obviously that is must to follow. Then we have a robust design elements. So whenever you will be designing your data model, you should put the robust design elements. What it means, robust design elements, it means your design should be future proof. First of all, it should not be like you did some workaround for today and after 10 days you will be changing that because there is a change. You when you will doing that, you will think in your mind what could be the futuristic aspects, what could be the possible inputs and outputs, and thinking that you need to take decisions. For example, right now you are saying uh, no two employees can have same name, but yeah, it is possible in future as well. Right now you don't have, but in future there is possibility there will be two people with same name and same date of birth, but with different address or something like that. So you need to be very careful, like deciding how one element like duplicacy detection should work, how my data should hierarchy should work, all that stuff. So that are the signs of a robust design elements. Then we have consistency across projects. Obviously, that is most important because, for example, you are following some nomenclature, best practices to select the names. In one of the table, I'm saying my table name is employee and underscore department name. But I have another table where I'm simply saying employee, where I will not be able to identify which department this data is for. Then it will become a problem. Okay, so you need to perform this consistency check every time and everywhere when you are creating a data model. Another example is, for example, you are saving dates somewhere. So for some of the tables, the date is date and week, day of week. All these time intelligence entities are available within your tables, and for other tables, you are creating a separate table to do all that stuff. So that's inconsistency, and that should not happen. Sixth one, like fourth one is reusing of models. Just not follow this order. They all are important. So next one is reusing of models. You should make reusable models. Like it should not be a model that you create and it cannot be used by some other department. For example, you are creating a data model where you are connecting your employee details, their salary details, and this the same information is required by some other department, and it should be like in a form that it can be reused by other people as well. So we will discuss about it, how to create reusable models, but yeah, that is one of the requirements. Better data quality, this is must. Again, there should not be duplicates, there should not be incomplete data, there should not be data which doesn't make any sense. So these are the good signs of better data quality. Then you have quality management. So this is data quality, but then you have overall quality management, which will make sure that you don't lose data at any point. For example, when it comes from a source to destination in your database, it will not lose data, or it will not be appended with unnecessary data, and the data integrity is maintained. So we will have a separate session to understand data integrity, what exactly it means and how important it is for our end users. Okay, so this is you know the basic elements that one good data model should possess. Now, when we talk about data models, they can be very easy and they can be like this as well. So when we talk about enterprise level databases, it is just an example. This can be only one tool. So you have one tool and you have a lot of data in that, and this could be the data model. So it initially it will look, see if one table is having a lot of columns or attributes. Similarly, this one, some are small, some are facts, some are dimensions. Yeah, we will understand about them. But yeah, it just looks scary, but it is not. If you follow all the best practices to develop a data model, you will never face any problem to uh, reverse engineering that or debug any problem that you will have in this data model, all that stuff. You just need to do the good things, follow the best practices, follow the regulations. That is it, and you are done. Okay, so no worry about that. Then I would also like to talk about this, this piece of information. You will hear these terms a lot. That is OLTP versus OLAP. OLTP stands for online transactional processing, and OLAP is online analytical processing. What exactly the difference is? Actually, the difference is within the acronym itself. Transactional processing is for the transactional data. For example, when you have like e-commerce website, it will be generating a lot of transactions. Like at this particular timestamp, let's say 9 hours 12 minutes, 16th January 2024, you have one transaction where this user bought this product at this price with this discount, blah 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 blah, all that stuff. Now you will have this data for each customer and for each transaction. So it will be whole lot of data that you will have. Transactional data is always huge. Consider this in mind. And transactional processing means if you want to know the exact, okay, I want to know at 9 hour 12 minutes 16 January 2024, who is the person who made the transaction. So it will go row by row, find in those billion transactions where is your transaction. That is called transactional processing, because it will go line by line, row by row, and do the processing calculate the output for you. For example, who bought X, like who is the customer who bought this product. This will be transactional. So it will find that specific transaction which is satisfying this condition. Then there is another processing that is analytical. This is kind of, you know, uh, summarized output. For example, if you want to analyze how many transactions are there who bought this specific product. So what it will do, first it will go row by row, find those rows. First of all, it will do a transactional kind of, not exactly transactional, but it will do the same thing, find the transactions. Then it will summarize, count them, like how many, like there are 10 transactions where the person bought this stuff, all that stuff. Okay, that's why it is a slow one. You can see it is slow queries. This is fast because you just go find the transaction and that is your answer. Here it will go find all those transactions satisfying this condition and then summarizing them, so it will be slow. Transactions, high volume of transactions. Here you will have a lot of transactions, okay, as I told, but here you have high volume of data, because when the analyzing, you will analyze a lot of transactions and then summarize them. Okay, normalization, denormalization, we will have a separate session for that, or how exactly it works, what is normalization, there are different levels, 1 to 3, all these things we will do. Okay, yeah, so this is for now, just it was just to tell you, you will hear these terms and what exactly these terms mean. Okay, so these are the two way of processing data from your data model. Okay, I think that's it for today, and we will continue with other topics in our next session. Thank you so much.